Have you ever wondered how the sun, our very own star, rotates in the vast cosmic theater? This celestial beacon, a fulcrum around which our reality spins, participates in a dance so grand that it's hard to fathom from our earthly perspective. The sun, you see, does not merely sit idle in the sky. It spins, it twirls, it pirouettes in a cosmic ballet that lasts for approximately 28 to 30 days. A dance so slow, so subtle, that we often forget it's happening at all. Yet this dance is far from insignificant. Each rotation of the sun plays a crucial role in shaping our world and the entire solar system. It governs the ebb and flow of solar energy, orchestrating a symphony of light and heat that sustains life on Earth. It influences the solar wind, shaping the magnetic fields of planets and directing the cosmic weather. It even stirs the cauldron of nuclear fusion at its core, forging the elements that make up the universe. Over the next 30 days, we will embark on a journey to explore this cosmic ballet in greater detail. We will delve into the mysteries of the sun's rotation, uncovering the rhythmic patterns and beautiful complexities of our star's dance. We will venture into the heart of the sun, exploring its fiery core and the nuclear reactions that power its movements. We will also witness the sun's influence on our planet, exploring the myriad ways in which its rotation shapes our daily lives and the world around us. This journey will not be a passive one. We will engage with the latest scientific research, drawing on the knowledge and expertise of astronomers, physicists, and other scientists who dedicate their lives to studying the sun. We will also invite you to participate in this exploration, encouraging you to observe the sun, ask questions, and engage with the mysteries of the cosmos. So prepare yourself for a journey like no other. A journey into the heart of the sun, into the rhythms of the cosmos, into the dance of light and life. Join us on this enlightening journey as we unveil the mysteries of our radiant star. As the first day unfolds, astronomers worldwide are poised to document the sun's celestial dance. It's an astronomical ballet that has been performed for over 4.5 billion years. Yet each rotation brings with it a sense of anticipation, a thrill of discovery. As dawn breaks, the sun emerges from the horizon, a radiant performer taking center stage in the cosmic theater. Its first rays of light brush the earth, a gentle touch that sets the rhythm for the day. Across the globe, astronomers stand ready, their eyes keen and instruments primed. They are the silent audience of this celestial spectacle. They're tasked to record the sun's every move, every subtle shift in its fiery waltz. With each passing second, they trace the sun's path across the sky, capturing its journey with unwavering dedication. With each passing day, the sun reveals a new facet of its mesmerizing performance. Day 5 brings a dramatic twist to the dance with a captivating solar eclipse. This celestial ballet takes an unexpected turn, as the moon glides between the earth and the sun, casting a temporary shadow on our world. This is no ordinary shadow, though. It's a cosmic spectacle that has mesmerized humankind for ages, turning day into night and unveiling the sun's elusive corona. This outer layer of the sun is usually hidden by its bright light, but during an eclipse it becomes visible as a halo of radiant light. Scientists eagerly seize this moment to study the corona's mysteries. They analyze its temperature, density, and magnetic fields, gaining insights into the sun's complex dynamics. These precious moments of darkness offer a unique window into the sun's secrets, enriching our understanding of this magnificent star. This fleeting shadow unveils the secrets of the solar corona, adding to the allure of our radiant star. On the 10th day, the sun unveils its true colors in a vibrant solar spectrum. Much like a prism dispersing white light into a rainbow, spectrographs allow us to dissect the sun's radiant glow into its constituent colors. Each hue is a testament to the sun's diverse chemical composition, a vibrant display of the elements that make up our star. The solar spectrum is not just a colorful display, it's a cosmic detective story. Each line in the spectrum corresponds to a specific element: hydrogen, helium, oxygen, carbon, and many more. All leave their unique signatures in the form of spectral lines. This is the language of the cosmos, written in light and deciphered by our spectrographs. Spectrographs don't just tell us what the sun is made of, they also reveal the sun's moods. You see, the sun is a dynamic, ever-changing entity. Its surface roils and churns, heated by the nuclear furnace at its core. This causes the spectral lines to shift, a phenomenon known as the Doppler effect. By studying these shifts, Astronomers can map the sun's magnetic field, track its rotation, and even predict solar storms. It's a bit like taking the sun's pulse, understanding its heartbeat and diagnosing its health. All this from a rainbow of light. But the solar spectrum isn't just about the sun, it's a universal tool. By comparing the sun's spectrum with those of other stars, we can gauge their composition, age, and even distance. It's a cosmic Rosetta Stone, allowing us to translate the language of the stars. So, as we watch the sun's slow dance, let's not forget the silent symphony playing out in its light. Each color, each line, each shift is a note in the celestial orchestra, telling us the story of our star, a story of fusion and fission, of heat and light, of creation and decay. Each color holds a tale of the elements forged in the sun's heart, fueling its fiery dance. Day 15 brings forth fiery outbursts as solar flares dance across the sun's surface. These flares, like cosmic fireworks, are eruptions of intense high-energy radiation from the sun's active regions. They are often associated with sunspots, those dark patches on the sun's surface, which are areas of intense magnetic activity. Solar flares are awe-inspiring displays of the sun's potent energy, but they're more than just celestial spectacles. They can have significant impacts right here on Earth. When the sun ejects these flares into space, it also releases a stream of charged particles, known as solar wind. This wind travels across the solar system at high speeds, carrying with it the sun's magnetic field. Upon reaching Earth, these solar winds can interact with our planet's own magnetic field, creating what we know as geomagnetic storms. These storms can produce stunning natural light shows in our skies, the auroras, also known as the northern and southern lights. But these solar storms can also have less charming effects. They can disrupt satellite operations, interfere with communication systems, and even cause power grid failures. That's why it's crucial to keep an eye on solar flares and the solar wind. Scientists have developed sophisticated tools to monitor and predict these solar events. They use satellites and ground-based observatories to track solar flares and the resulting solar winds, helping us prepare for and mitigate their potential impacts. So, as we watch these solar flares light up the sun's surface, we're not just witnessing a dazzling display of cosmic energy. We're seeing a critical part of the Sun-Earth relationship, an intricate dance of magnetic fields and charged particles that reaches across 93 million miles of space. These radiant bursts of energy illuminate the cosmos, marking the halfway point in our journey. But the sun's dance is far from over. As we continue to observe, we'll delve deeper into the mysteries of our closest star and its influence on our planet. As we reach day 20, the sun reveals its rhythmic heartbeat through the appearance of sunspots. These dark, cooler areas on the sun's surface are not mere blemishes in our star's radiant complexion. Rather, they are magnetic disturbances, like silent whispers of the sun's vast, turbulent interior. Sunspots are the visible manifestation of the sun's magnetic fields, which twist and churn with the star's rotation. They are like the tempo in a piece of music, providing us the rhythm to understand the sun's complex magnetic dance. The larger the sunspot, the stronger the magnetic field, and the more intense the dance becomes. Interestingly, sunspots do not appear randomly. Instead, they follow a specific pattern known as the solar cycle. This cycle lasts about 11 years on average, and it's characterized by an increase and decrease in the number of sunspots. At the peak of the cycle, known as the solar maximum, sunspots are abundant and solar activity is high. Conversely, during the solar minimum, sunspots are scarce and the sun is relatively quiet. The solar cycle is a fundamental aspect of solar physics. It influences space weather, which can affect satellite communications and power grids here on Earth. Moreover, understanding the solar cycle can help us predict solar activity, including potentially harmful solar storms. But the solar cycle is not just about practical implications. It's also a profound reminder of the sun's dynamic nature. Our star is not a static ball of light, but a living, breathing entity. It dances to its own rhythm, dictating the tempo of the cosmic ballet. As we trace the sunspot's patterns, we're not just observing a celestial phenomenon. We're listening to the sun's magnetic heartbeat, feeling its pulsations reverberating through the vast expanse of space. These magnetic disturbances offer a glimpse into the sun's cyclical nature, setting the stage for the final leg of our journey. As our 30-day journey concludes, we reflect on the sun's mesmerizing performance in the cosmic theater. From its first dawn to the grand finale, the sun's slow dance has captivated our attention and inspired our curiosity. Throughout this journey, we have witnessed the sun's graceful waltz across the sky, its spectacular solar flares, and the rhythmic cycle of its sunspots. We have delved into the mysteries of solar eclipses, unraveled the secrets of the solar spectrum, and felt the awe-inspiring power of the sun's radiant energy. Each day of observation has deepened our understanding of the sun's role in the cosmic ballet. Its rotation, a dance that takes 30 days to complete, not only shapes the sun's behavior but also influences the entire solar system, from the smallest particles to the largest planets. As the curtain falls, we are left with a deeper appreciation for the sun's slow dance, a celestial waltz that shapes the rhythm of life.